the product rule. The product rule is a method used to find the derivative of functions. By definition, if f and g are both differentiable functions, then their product p of x, which is f of x times g of x, is also a differentiable function, and p prime of x equals f of x times g prime of x plus g of x times f prime of x. In English, this means that if you have a function composed of two smaller functions being multiplied together, then its derivative is f of x times g prime of x plus g of x times f prime of x. Or put even more simply, it's the first function multiplied by the derivative of the second function plus the second function multiplied by the derivative of the first function. It's essentially a recipe or a formula that you can use to find the derivative of different functions. What can be difficult in using the product rule is identifying f of x and g of x, or seeing the two functions that are being multiplied together. So let's get some practice. For each of the following functions, let's see if we can use the product rule and if we can identify f of x and g of x. In our first example, we have x squared times ln of x, which we can definitely use the product rule for. In this case, we see that f of x, or the first function, is x squared, and g of x, or the second function, is ln of x squared. So with this, we'd easily be able to use our product rule formula. In our next example, we have cosine of x divided by ln of x, which isn't something that looks like we can use the product rule for. But we can rewrite the function to be something that we can use the product rule for with some algebraic manipulation. And in this case, we can take ln of x out from underneath cosine of x to get cosine of x times 1 over ln of x, which is exactly the same problem and equal to cosine of x divided by ln of x. But in our bottom equation, it's much easier to see f of x and g of x, or that the first function is cosine and the second function is 1 over ln of x. With this information, we can definitely use the product rule to solve this second example. Let's actually try solving a problem. In this one, we have 10x cubed plus 5x squared minus 7 times 20x to the 8th minus 7. In this case, we can see that f of x, or the first function, is 10x cubed plus 5x squared minus 7, and g of x, or the second function, is 20x to the 8th minus 7. So using the product rule, we have the first function being multiplied by the derivative of the second function, plus the second function being multiplied by the derivative of the first function, or this longer answer at the bottom here. And since we're just trying to find the derivative of p of x, we can just leave it as is, and there is no need for us to simplify this. And let's try with one more problem. In this case, we have x plus 2 divided by 3 all to the power of 2. Now again, this is something that looks like we might not be able to use the product rule, but with a little bit of algebra, let's see if we can turn this into something we can use the product rule for. Let's start with dealing with the exponent on the outside. Let's square both the numerator and denominator, getting us x plus 2 squared divided by 9, and then factoring out the top, we have x squared plus 4x plus 4 divided by 9. Now this looks like our example from earlier, so let's take out the denominator from underneath the numerator to give us x squared plus 4x plus 4 times 1 over 9. Again, it's the same exact function as the one at the top, but in this case, we can see f of x and g of x much easier, and now we can use the product rule. And in this case, we have x squared plus 4x plus 4 times 0 plus 1 over 9 times 2x plus 4. Let's simplify the first half since it's just being multiplied by 0, giving us 1 over 9 times 2x plus 4. And then simplifying this a little further, we get 2x plus 4 divided by 9, which is the derivative of our function. Now we have seen two examples of the product rule and been given a definition.